Hi guys, welcome to another screencast. This time it's on transposing formula. So in the class we've been covering this topic and some of you have been a little bit confused about it, some blank faces, some not so happy comments in class. Okay, so I've put this screencast together to hopefully just go through the basics and to hopefully build on your knowledge of transposing formula. Now it is very important that you can transpose formula correctly because if you can't, especially in the higher papers, you're given standard formula, you need to be able to transpose it so that you can actually answer the question. So this is really an important subject. Okay, we don't just do it just for the sake of it. So hopefully watch this video and we can build on your skills and knowledge. So the objectives of this screencast are to describe the basic rules of transposing engineering formula. We're then going to transpose some simple engineering formula just to get some practice in with the basic rules. And then we're going to transpose some more complex or slightly more complex engineering formula and evaluate data. Okay, so we're going to take a standard formula, we're going to transpose it to find the variable or the unknown that we want, and then we're going to punch in some data and hopefully come out with an answer that we want. And just one other note, all the formula that you're going to see in this screencast are going to be used throughout your course. Okay, so there's none in here that you won't see. All the formula in here you will see during your course, and so hopefully they will help you with your exam success, which are coming up shortly. So describe the basic rules for transposing engineering formula. And then what is transposition? Okay, in simple terms, it is moving around a standard formula to find an unknown. Okay, so we might have a variable that we don't know. Okay, length of the side, pressure in a pipe, a temperature, volt, amps, current, for example. We need to be able to move around a standard formula to find an unknown value. Okay, so for example, this one here, we have a standard formula for Pythagoras, which is c squared equals a squared plus b squared. So from this we understand that the side of a squared plus the side of b squared will equal the side of c squared. Okay, fantastic. But in an exam you'll get a standard formula like this. Okay, so you get a standard formula and the chances are, okay, as we move up the levels, you are not going to get a question where you just punch in the numbers and it spits out an answer for you. You need to be able to transpose those. Okay, so for example, you'll get the standard formula, but you might get a question where you know the side of C and the side of B, so you need to be able to transpose the formula, for example, to find the side of A, or you might know C and A and have to transpose it to find the side of B. Okay, unfortunately you don't get all of these variables for all of the formulas that you're going to use. We need to be able to transpose. So transposing, okay, just remember that an equation or a formula is balanced. Okay, see it as a set of scales. Okay, so where this side equals, okay, this side. Okay, and whenever we do anything in transposing, what we do to one side we need to do to the other. Okay, so if you add and subtract something, or add or subtract something on one side, okay, you must do it to the other. If you divide or multiply on one side, you've got to do it to the other. Okay, so really important that what you do to one side you must do to the other. Okay, otherwise we're in trouble. So what you might hear people say is that as a particular value, okay, crosses over the equal sign, okay, it changes. Okay, so if you've got a positive number on one side, okay, it changes to a negative on the other. If you have a negative on one side, and as it transfers across the equal sign, it becomes a positive number. A multiplication becomes a division. Okay, a divisible becomes a multiplier. And if you have a square, something squared, okay, to get rid of that square, you need to square root. Okay, so we do the opposite. Okay, and we're going to come back to this table as we go through this screencast. So now back to our Pythagoras as a warm-up exercise. Okay, so we've got our standard formula, so c squared equals a squared plus b squared, and we want to find out what b squared is going to look like. Okay, so we know, for example, we know the hypotenuse, which is c. Okay, and we know the the adjacent, for example, but we want to find out what the opposite side is, we need to transpose our standard formula. Okay, so first thing we're going to do is, if you look at what I've done here, we want to get b on its own. Okay, so a is a positive number. Okay, so what we need to do is we need to get rid of that. So we effectively need to take it down to 0. So to do that, we subtract a squared from a squared. Okay, so that's, so say for example, if a squared was 5, for example, okay, we want to get rid of that back down to 0, so it's not there anymore. We would then subtract 5 from it, wouldn't we? 5 minus 5 would equal 0. So that's what we're doing here. So we're subtracting a squared from a squared to get rid of it. Okay, but remember what we do to one side. Okay, so see here, a squared minus a squared. What we do to one side, we must do to the other. Okay, so very important that. So these are still balanced. Okay, this is still balanced. Okay, but also all we need to do now is then just tidy it up. Okay, so a squared minus a squared, that cancels out, that goes back down to 0. So we can cross those out, that gets rid of those. Okay, and then we can tidy it up a little bit further, and we can get our finished formula like so. So c squared minus a squared equals b squared. Okay, and that's our finished formula. That's all we need to do. Okay, then we can punch in our known data and we can work out what our length of side b squared will be. Okay, some of you may be quite comfortable with transposing formula. Okay, I'm going through this step by step so you can see the process. Not only that, in engineering there is more than one way, as they say, to skin a cat. So you might find other people will teach other methods for transposing formula, and it will get to a point in your mathematics and engineering career where you can just start to do these off the top of your head. You won't need to go through this process at each time. Okay, so we're going to go through the long-winded method each time during this screencast, but in the long run you should be able to just flick these around in your head and have just being able to do it off the top of your head. It's like playing sport. It's all about practice. So you'll go. So pause the video for a minute and just look at the following formula. Okay, so c squared equals a squared plus b squared, which is our Pythagoras. Okay, but this time we want to find out what a squared is. Okay, so we know c squared and we know b squared. We want to find out what a squared is. Okay, so just pause the video and have a go at transposing it so that you get a formula so that you can calculate what a squared is. Okay, so how did we get on? Okay, so this time we want to get a squared on its own, so we're going to need to move b squared. Now b squared is a positive number. Okay, so we can see that plus b squared. Okay, so b is positive, so again we're going to have to move this, so we want to get it down to 0. So hopefully you should have all minus b squared on one side, and then don't forget what we do to one side we do to the other. Okay, now b squared and minus b squared, they cancel each other out. Okay, which then means we can tidy up our formula and we should have come up with that as a correct answer. So a squared equals c squared minus b squared. Okay, so that's simple formula. Okay, but they're just little tricks. Okay, if you've not done very much of it before, okay, you maybe switched off over the summer. Okay, thought GCSEs were out the window. I won't ever use that again. Oh dear. Okay, so trying to draw it all back into the front of the mind. Okay, ready for our engineering mathematics exams. So again, as you can see from there, on one side we had a positive, so for example positive a squared or positive b squared, and as it transferred across the equal sign it became a negative value. Okay, so we minused it on the other side. Okay, and remember what we do to one side we do to the other. Moving on to the next one. Okay, so this is our Ohm's law formula. Okay, so for this formula we have voltage equals I. Okay, might sound strange, but this I is for current and R is for resistance. Okay, so in algebra these two are side by side. Okay, so that means that it's going to be V equals I times R. And for example, okay, we may have remember it's an equation, so it's balanced. Okay, so I say, for example, we have 2 amps with a resistance of 6 ohms. Okay, 2 times 6 would give us 12 volts. Okay, so that's balanced. Okay, can you see how that's balanced? So now what we need to do is we're going to look at, in the next example, okay, in this example we're going to look at, we know, for example, the voltage, and we know how much current is being drawn in the circuit, so we want to work out the resistance of a particular circuit. So going back to our chart on our side, okay, these two are times together. Okay, so we've got a times here. So what's effectively going to happen is we're going to use it as a divide by. Okay, and how we're going to do that is, so we want to get R on its own, so we need to move I. So the next step you're going to do is divide by I. Okay, so to move these apart, we're going to divide by I on one side. Okay, so I times R divided by I equals V. Okay, that's not quite right, is it? Because we haven't. Okay, what we need to do to one side, we do to the other. So we need to do that to the other side. So we've got V divided by I equals I times R divided by I. These two will cancel out. Okay, so we now have, which will leave us with, our voltage divided by current equals our resistance. Okay, so I'll just pause for a second for you to look at that. So again, we have two values multiplied together. To break them apart, okay, you need to divide by the one you want to move. Okay, so we wanted to get R on its own, so we're going to move I across. Okay, we wanted to get I over to the other side, so we divided by the one we wanted to move. So I divided by I. Okay, and then what we do to one side, we do to the other. Okay, divided by I. You can cancel out these two, which would then leave us with V divided by I equals R. Okay, so voltage divided by resistance, I apologize, voltage divided by current equals our resistance. So if we had 12 divided by 2, okay, that would give us our 6 ohms. Okay, we're going to put all these rules into practice into more complex formula later on. Okay, so just bear with me. Okay, so it's just going through the basic rules. So if you've got two values that are times or multiplied together, okay, to break them apart you need to divide by the one you want to move. Okay, which then gives us that R on its own. Right, okay, so we have something a little bit new. Okay, so we have C equals Q divided by V. Okay, so that's the capacitance of a capacitor divided by the electrical charge in coulombs, which is Q, divided by the voltage. Okay, so what do we want to look at on this one? Okay, so we want to get Q on its own. Okay, so the next step is we'll look at our rules. Okay, this one's a little bit trickier. Okay, what we're going to do with this one is we are going to do a couple of steps. So the first thing we want to do is we want to get Q on its own, so we're going to move V. Okay, and so V is a divisible, is the denominator, so we're going to move that, we need to multiply it. So we're effectively doing Q divided by V times V. Okay, as our first step. Yes, that's right. We need to, what we do to one side, we do to the other. Okay, so C times V equals Q divided by V times V. So that's balanced now. We've balanced our formula out. Okay, by doing what we did on one side, we did to the other. Now, this is effectively V divided by V. They cancel each other out, which then leaves us with the formula C times V equals Q. Okay. So the ones you want to move, so if you've got the denominator, the one you want to, and that's the one you want to move, you need to times it by that value or that variable, okay, and then do the same on the other side here. Okay, so C times V equals Q, and that's our finished equation. You could then go ahead and punch in the values to find out what the electrical charge would be in coulombs for that, with that formula. That's annoying. Okay, so on this next one we have the same formula again, but this time we want to make V the subject. Okay, so this requires a little bit more flicking round. Okay, and going back. Okay, so this is a divide by. Okay, this is the denominator. Okay, so what we need to do with that is we need to just slightly different approach to this one. Okay, we are going to, first of all, we're going to move V. Okay, we're going to get V over to the other side. Okay, so to make it a nice linear equation. Okay, so, and again, what we do to one side, you do to the other. They cancel each other out. Okay, and we end up with C times V equals Q. Excellent, that's what we wanted. But, okay, we still need one more step to go. And so basically what we do is we then, these two, so C times V, okay, we need to move. Okay, so we need to move C because we want V on its own. So we divide by C on one side, and what we do to one side we do to the other. Okay, those two then cancel each other out. Okay, which then leave us with our formula V equals Q divided by C. Okay, so it's easy. I find it easier to, if you have something that is a divide by like so. Okay, so for example, we're looking for V, we want to get the denominator on its own. Okay, to go through a process of making it linear and then splitting the two apart. Okay, so just adding in that extra step. So something slightly more complicated now. Okay, this time we have velocity, or should I say the final velocity squared equals the initial velocity squared plus 2 times the acceleration. Okay, so final velocity equals initial velocity plus 2 times the acceleration. Okay, and this time we want to get u on its own, not u squared, but u. Okay, that's what we're looking for. So there's a number of ways we can do this. Okay, and some people have a preferred method, others will do it one way, others will do it in another. Okay, so the first thing I would want to do is, okay, I'm going to get rid of this. Okay, I want to move this over to the other side. Okay, and because we're moving all of this together, okay, we don't need to split these two apart. We can just move the whole lot over to the other side. So what we are going to do is we are going to move. So we've got a positive number, so positive 2a. Okay, to get that down to 0, yeah, that's right, we need to minus 2a. Okay, but yes, you're right, what we do to one side we do to the other. Okay, so now we have the final velocity squared minus 2 times the acceleration equals the initial velocity squared plus 2 times the acceleration minus 2 times the acceleration. So these two are now effectively 0, so they cancel each other out. So that leaves us with v squared minus 2a equals u squared. But remember, we wanted to get rid of the square. We wanted u on its own. We wanted to find out what the initial velocity is, not the squared initial velocity. So from here, we need to take our variable, which is squared, and square root it. That should be v squared. Okay, just like above. I don't know why it's done that. So the square root of v squared minus 2a equals u. Okay, so by square rooting it, okay, we've got rid of that squared. Okay, so now we know what our u is. Okay. Oh, this one looks a little bit more tricky. So we have transposing more complex engineering formula and evaluating the data. Okay, so this is a formula that you're going to see in your exam. Okay, so you will come across this. We'll practice it in class, but you will see this. Okay, so in this example, we want to make V2. Okay, so let me just explain this formula a little bit. Okay, so what we've got is we've got two different states. Okay, so we've got an initial and a final. Okay, so for example, the initial pressure times the initial volume divided by the initial temperature is equal to the final pressure times the final volume divided by the final temperature. Okay, so we want to get, so for example, in this example, we know what P1 is, V1 is, and T1 is. We'll know what P2 is and T2 is, but we don't know what V2 is. Okay, so we need to transpose the formula to find out what V2 is. Okay, it's not V squared, it's just V2. So it's telling us it's subscript, so it's just telling us that it's a different state. Okay, it's volume, but it's a different state. Okay, you might find that it might be PI and VF, for example. Okay, this subscript depends on who's writing the formula. Okay, but usually in our class you will see it like so. So to our rules. Okay, hopefully you've studied this a little bit now. Okay, so we're going to use these two down here to transpose our formula. Okay, now the first thing that I like to do is get rid of the low hanging fruit, shall we say. Okay, so anything, the denominator, we want to move this. So the first thing you're going to do is get rid of this T2, okay, because we want to get V2 on its own. So we're going to move T2. So what I've done here is I've got P2 times V2 divided by V2. I want to move T2, so is a divisible, so it becomes a multiplier. So I've timesed it by that. Okay, so T2 times T2. Okay, and what I've done to one side, I do to the other. Those two then cancel out. Okay, which leaves me with this formula here. Okay, so P1 times V1 divided by T1 times T2 is equal to P2 times V2. Bit of a mouthful. Okay, so the next step, okay, we need to do is we've completed one step. Now what we need to do is complete the second step. So we need to break P2 and V2 apart. Now they're multiplied together, so we're going to divide by, that's right, the one we want to move, and we want to move P2. So we want to move P2 over to the other side. So it's a multiply, so it's going to become a division. Okay, so we divide by the one we want to move. Okay, so on this one I've divided by P2, and what I've done to one side I've done to the other. Okay, so P2 down here and P2 down here. Okay, so those two then cancel each other out, which then brings us to our final formula of to find V2. So the final volume, okay, so V2 is equal to the initial pressure times the initial volume divided by the initial temperature times the final pressure times, and all of that times by the final temperature. Okay, and that is our completed equation. Okay, so now we can go ahead and we can punch all these numbers into a calculator and work out what we want. What you may find is, in some examples, you may find that this T2 here is actually on top as well. So it would be P1 times V1 times T2 divided by T1 times P2 would equal V2. Okay, let's click back on that so you can see it. Okay, spend a little bit of time on that and just look at the steps that I've taken. Okay, as you get more confident with transposing formula, you will see that it becomes second nature and you'll be able to move formula around much quicker. Okay, but especially in exams, okay, when being able to transpose formula is part of the criteria, write down these steps. Okay, because even in your notes, okay, if you write down these steps, then your examiner or whoever's marking the paper can then turn around and say, okay, I can see the mistake you've made. So you still might be able to glean some points. Okay, but just be careful. Okay, and we're going to come back to one other trick you can do once you've actually transposed the formula as well. Okay, so that's our final formula. Okay, so now we're going to look at transposing more complex engineering formula and evaluating data. Okay, so in your exam, the chances are you're going to get a question very similar to this, okay, using this formula. Okay, so let's have a look at the question. Okay, a gas has an initial volume of 2 meters cubed and an absolute pressure of 350 kilopascals. Its initial temperature is 150 Kelvin. The gas is compressed to a final pressure of 3.5 megapascals, during which its temperature rises to 375 Kelvin. Calculate its final volume using the formula derived below. Okay, so initial volume, 2 meters cubed, absolute pressure. Okay, so that's a combination of absolute pressure and gauge pressure. Absolute pressure, so those two added together is 350 kPa. And then the initial temperature is 150. Okay, so we know all of these. Okay, the gas is compressed to 3.5 megapascals, so we know what P2 is. And during that time, the temperature rises to 375 Kelvin, which is T2. Okay, so we need to find out what V2 is to calculate its final volume. Okay, so we need to find out what V2 is. I know we did that in the previous section. So what I want you to do is I want you to pause this. Don't look at your notes. Don't flick back through the video, and just try and use what we've done so far to transpose this formula below to make V2 the subject, so that we can then calculate the final volume. Okay, so pause the program and then come back in a minute when you've completed it. Okay, so hopefully we would have come back with something like this. Okay, so this is just a recap. We've done this before. Okay, so we're after V2 and we want to move T2, so it's the denominator, so we would times by. Okay, so we times by T2. Okay, and what we do to one side we do to the other. Those two cancel each other out, which then leaves us with this formula. From here we now need to split up P2 and V2, so P2 times V2. Okay, so they're times by, so you're going to divide by the one you want to move, and the one we want to move is P2. Okay, the two P2s on the right hand side cancel each other out, which then leave us with the formula: the initial pressure times the initial volume times the final temperature, divide by the initial temperature times the final pressure, equals our final volume. Okay, so that's our formula that we're going to use. Okay, and so the next stage is to punch in the values from the question. Okay, so from here we know that the initial pressure, so P1 is 350 kilopascals, so 350, and then we're using engineering notation here, so kilo is 3 times 10 to the power of 3. Okay, so 350 times 10 to the power of 3 times 2. That's our top line. Okay, and then on the bottom line we've got T1, which is 150 Kelvin, times 3.5 megapascals, so that's going to be times 10 to the power of 6. So engineering notation again. That eliminates the need to write loads and loads of zeros, and that's all going to be times by 375 Kelvin. Okay, now if you punch all that into your calculator, it should give us our our final volume. Okay, which is going to be 0.5 meters cubed. Okay, so we've got 2 meters cubed. Okay, so for example, like a piston in a cylinder, for example, the volume of that piston, okay, or for example the air gap in that cylinder has been compressed from 2 meters cubed all the way up to 0.5 meters cubed, and in that process the pressure is increased and so has the temperature. One way you can go back and check the values that you've put in is by putting these back into the original formula. Okay, so taking this value here plus the ones we've been given and putting them back into the original formula and seeing if they actually equal each other. Okay, so in this formula, P1 times V1 divided by T2 should equal P2 times V2 divided by T2. Okay, if that doesn't, then we've made a mistake somewhere. Okay, from this example I know it does. Okay, but just go ahead and put these values back in and just to double check. Okay, they should equal each other out. Okay, you may, if you've got more complex numbers, okay, so for example where you're actually rounding, okay, there might be a slight variation, but it shouldn't be too great. Okay, so that's why it's important to read the exam paper and check what you need to work to, okay, and how your answer should be expressed. Okay, is it to 2 decimal places, 3 decimal places, 4 significant figures? Okay, do they want it in engineering notation as well? Okay, so check your answers, put them back in, put the values into the original formula just as a double check. So we could call that a bit of a sanity check. Okay, just punching them back into the original. Okay, I understand under exam conditions when time is tight, okay, you might not have that luxury, okay, especially if you spent a bit of time sort of fiddling with the formula trying to get it right. Okay, but if you have, double check at the end by punching the original the values you've got back into your original formula, okay, and making sure that they add up. So going back over the basic rules, okay, so remember, okay, if you've got a positive on one side, as it transfers across, okay, it will become a minus will become a positive. 2 values multiplied, the one you want to move will become the denominator. Okay, if you've got a denominator on one side, okay, it will be multiplied on the other. And if you've got a square, okay, and you want to get rid of that square, for example, you want to find a on its own, you use the root to get rid of that squared value. And one other important thing to note is, remember, what you do to one side, you do to the other. Okay, don't leave your equation out of balance. Okay, so just one thing to remember. And so hopefully that has achieved our objectives, okay, of describing the basic rules of transposition. We've transposed some simple engineering formula, and we've transposed some more complex formula, and we've evaluated the data. Okay, and these are all in formula that you will see. Thank you very much.